Hi students, I welcome to all of you to this session of fluid machinery. Dear students, myself Dhiraj Mandol, Assistant Professor JIS College of Engineering, Kolani. Today we are going to discuss about the numerical analysis on inward radial flow reaction turbine. As all of you know that the JIS College of Engineering is taking an initiative to battle coronavirus, that is COVID-19, and it is an initiative by JIS College of Engineering to work from home, and I hope all of you are getting benefited on this initiative. So let us discuss. The problem number 1, last class I gave you some assignment. I hope all of you have submitted. As per my knowledge, 60 to 70% student submitted assignment. If you have not submitted the assignment and if you have not seen the previous lecture, please see it. That is your lecture number 22. This is your lecture number 23. Let us discuss. A reaction turbine works at 450 Newton under a head of 150 meter. So head is given and RPM is given. Its diameter at inlet is 120 centimeter. That means D1 is given. And the flow area is 0.4 meter square. So flow area is 0.4 meter square, means area is equal to pi D1 into B1 is equal to 0.4 meter square. At inlet it is given, na? Okay, next, the angle made by absolute and relative velocity at inlet are 20 degree and 60 degree. So 20 degrees is the alpha angle made by absolute velocity of the, so this one is your 20 degree, and theta is equal to 60 degree. You can see this one is a theta, clear, respectively. Within the tangential velocity, determine the volume flow rate, that is discharge, the power developed, and the hydraulic efficiency. Assume the rel at outlet B0, that means beta is equal to 90 degree. So VW2 is equal to 0. So as you know that this is the velocity triangle where this is your V1, this one is your VW1, this is your VU1, this one is your VR1, this is your VF1. Okay, and this angle should be alpha because it is your guide blade angle, and this is your guide vane angle, that is your theta. As beta is equal to 90 degree, this one is your 90 degree, so VF2 is equal to V2, and this one is your U2, this is your VR2, and this angle is your phi. So I think the velocity triangle, it is clear because already you have discussed many times. Now the VW2 is your 0, so you have to find out the discharge. So you know that the discharge is what? Area into velocity of flow. So area is equal to pi d1 b1 into vf1. Now pi d1 b1, it is given 0.4. So you have to find out vf1. So that is the question. You have to, how we can find out the vf1? You know the alpha is given. This is your alpha. This v1, it is given. Is it given? The v1, this is your alpha, this is your vf1. Now you know that this alpha is given. Alpha is equal to 20 degree. Am I right? So how we can find, and this is your u1 and this is your vw1. So ultimately I have to find out vf1. To find out vf1, you need to know either v1 or you need to know this vw1. So how we can find out? Let us discuss. You can see from the diagram, the u1 you can find out easily because pi d1 n by 60, that is given. So can you find out the u1? Because d you know, e n you know. So 28.27 meter per second, that is your u1. u1 is the wheel velocity. Okay. So can I find out the tan alpha? Tan alpha is equal to vf1 by vw1. Now alpha we know, Am I right? Alpha. So alpha we know, but alpha no, but VF1 I don't know, and VW1 also I don't know. VW1. Now how we can find out the VW1? So that is our question right now. How we can find out VW1? We know that the relation between the VF1 and VW1 already I have got. VF1 by VW1 is equal to 10 alpha means 1020. So VF1 is equal to 1020 into VW1, isn't it? But from another, theta is given. Tan theta is equal to what? VF1 by VW1 minus U1. Can I write this? This is your tan theta. So mathematically, this I can write from this triangle, tan theta is equal to VF1 by VW1 minus U1. Now you know that this is your equation. Now this VF1 can be written as 0.364 VW1, because VF1 is equal to tan alpha into VW1. So put the value of VW1 as VF1 here. So VF1 you just put the value. So you will be getting in terms of VW1. So ultimately VW1 you will be getting this one 35 point, because only unknown is your VW1, because tan theta theta is equal to 60 degree and tan 60 is equal to root 3. Clear? Okay, now if it is clear, then we can easily find out VF1, because VF1 is equal to VW1 into tan alpha, isn't it? So ultimately VF1 is equal to 13.027 meter per second. So put the value, you will be getting the answer. So discharge is equal to this. Discharge is equal to pi d1 b1 VF1. So ultimately your answer is equal to 5.211 meter cube per second. I hope this problem clear. Now let us discuss the next problem. Next problem, next part. Because there are 3 questions. Volume flow rate you have found out. Now you have to find out the power develop. So all of you know that power develop. You know the formula, basic formula. The work done per second on the turbine is given by rho q into VW1 U1 by 1000. Okay. So rho q VW1 already I have got, U1 I have already got. By 1000 करो तो मिल जाएगा आपका ये 5272.4 kilowatt. Clear? And VW2 here it is your 0, not 2. Okay. So this is your ultimately work done or power in kilowatt. And hydraulic efficiency, as VW2 0, so it should be your hydraulic efficiency VW1 U1 by GH is equal to hydraulic efficiency. So I am not going to discuss how this equation is coming, because many time I have solved this problem. Okay. Now next problem is your 17. Problem number 17. You can see problem number 17, an inward radial flow. Again a problem is given on inward radial flow reaction turbine. Inward radial flow reaction turbine has external and internal diameter is your 0.1 and 0.6 respectively. So diameter d1 1.0 and 0.6 d2. Okay, respectively. The hydraulic efficiency of the turbine is 90%. So runner power by water power given 90%. When the head at the inlet is 36 meter, the velocity of flow at inlet is 2.5 meter per second, and discharge at outlet is radial. Radial means, again I am telling you, as this is given radial, that means beta is equal to 90 degree. Clear? And the velocity of flow at outlet is equal to VF2 is equal to 2.5 meter per second. Now if the vane angle at the outlet is given, okay, 15 degree, that means phi given, and width of the wheel means B at the inlet, V1 is given, and outlet wheel is 100 millimeter at the inlet and outlet, both are same. Determine the guide blade angle alpha, speed of the turbine n, vane angle of the runner at inlet, that is your theta, volume flow rate of the turbine, that is q, and power. Clear? So d1 is given, you can see d2 is given, and this is your velocity triangle because beta is equal to 90 degree. How you can say? Because the radial at the at the outlet, the velocity is your radial. So absolute velocity, this vf2 is equal to v2. Okay, so where you know d2 is given, hydraulic efficiency given, h is given, head, vf2 given, vw2 you know automatically it will be 0 because beta is your 90 degree, phi is 15 degree also given, b1 is equal to b2. Okay, so the hydraulic efficiency we know that vw1 u1 by gh. So ultimately from this equation vw1 u1 you can find out 317.85. now what you need to find out? You need to find out the theta. Now you know this you have got. Now we know that tan phi is equal to vf2 by u2. So vf2 already it is given, u2 not given, phi given. So can I find out u2? Because only vf2 sorry u2 is unknown here, so u2 you can find out from this equation. Now as you have got u2, so u2 is equal to pi dn by d2n by 60. So put the value of d2 and n, you will be getting n. That is your answer, one answer. So because you know n fine, that means n you have to find out the rotational speed. So 296.98 is the answer. Clear? Now similarly u1 is can be written as pi d1 n by 60. So from this equation d1 is given, n given, so u1 you can find out easily because n already have got na. Now next point you have to find out the vw1, and vw1 u1 is equal to already have got 317.85. now u1 already right now I have got, so vw1 can I find out? Okay, I can find out. Now we know the continuity equation, q is equal to area into velocity. Here velocity of flow you will be taken into consideration. So a1 vf1 is equal to a2 vf2, or you can write pi d1 v1 into vf1 is equal to pi d2 b2 into vf2. So as we know b1 and b2 same, pi same, d is different, so d put the value of all, put all the value, you will be getting vf1 because d2 you know, d1 you know, vf2 you know. So 1.5 meter per second is vf1. Now the case is what is tan alpha? Tan alpha is equal to vf2 by vf1 by vw1. This one is your v1. So vf1 already I have got right now. Tan alpha I have to calculate. vw1 already it is calculated from here, isn't it? So the alpha is what? Alpha is equal to 4.19 degree. Okay, and speed of the turbine is 296.98 rpm. And at last you have to calculate the power, and number 3 is yours same angle of the runner at outlet. The angle is your theta already. Theta it is, why I have to calculate theta? Because it is given na, it is given, theta is given, theta is given. 1 minute please. 15 degrees what? Vane angle at the outlet. Oh sorry, phi is given, theta you have to calculate. Yes, I'm sorry, theta you have to calculate. So let us calculate the theta, tan theta. So tan theta is equal to, this one is your theta, this is your vf1, and this one is your vw1 minus e1. So tan theta is equal to vf1 by vw1 minus e1. So put all the value, you will be getting tan theta 17.05 degree. And second last question was volume flow rate of turbine, and it is you know pi d1 b1 into vf1. Put the value, you will be getting 0.4712 meter cube per second. Clear? And power is very easy. You know that work done work done per by 1000. So work done is what? Rho q into vw1 u1 plus minus vw2 u2. Here basically beta is your 90 degrees, so vw2 will be 0. So that is why this part you have to take by 1000. So ultimately 149.76 kilowatt is the answer. That is your power developed, okay, in kilowatt. So I think it is clear, and this is the end of the lecture. This 18.8, it is you have to solve in your home, as I have discussed a lot of problem. So these three question, it is your homework, that is your assignment. Submit this assignment to my official mail, that is your dheeraj.mondol@jscollege.ac.in, and this lecture will be available in my YouTube channel DM Study Center. Okay, see this lecture, and don't forget to write done in the comment section. That will be your attendance. Okay, and one more thing, if you want to get all the notification of every video, then subscribe that particular channel DM Study Center, and don't forget to press the bell icon, because you will be notified when some video lecture will be uploaded there. One more announcement, there another course I am just uploading. So you just keep visiting my YouTube channel, all the notification you will be getting. Okay, thank you for listening.